Alright, what's up guys? In this video we're going to pick up some calculus and we're going to do another integral here. So we're asked to evaluate the integral from 0 to 1. We got 2 raised to the 4x dx. So this is just another one of these general base integrals. So we'll begin with a simple u substitution. We'll pick u to be 4x. We'll differentiate it. That gives us 4 dx. And we'll end up with 1 over 4 du is equal to dx. So I'm going to pull the 1 over 4 out, so that's just a constant. Leave the limits blank because we're going to have to change them, and then the integral becomes 2 to the u du. Let's change the limits right quick. Remember, anytime you do a u substitution for a definite integral, we got to change the limits. So u was 4x, so let's change them. So we'll stick in a 0, so that's obviously 0. And then sticking in a 1 just gives us a 4. So now the limits change from 0 to 1 to 0 to 4. So now we integrate the integral from 0 to 4 for 2 to the u du. So remember, if I have the integral b raised to the x dx, remember that's just 1 over ln of b multiplied by b raised to the x plus c, or you can write it as b raised to the x all over ln of b plus c. However you choose to write it is fine. It's the same thing. Remember the restrictions on this formula. A lot of students forget about. Remember that b needs to be greater than 0, and also remember that b cannot equal positive 1 because we would get ln of 1, which is 0, which would give us division by 0, which is undefined. So make sure you keep in mind those restrictions. So with that being said, in our case, with the 1 over 4 being on the outside, the integral of 2 to the u du from 0 to 4, well, 1 over 4 is a constant, so this becomes 2 to the u all over ln of 2, and we just got to evaluate it from 0 to 4. So this becomes 1 over 4. And we substitute in our 4 first, and then we substitute in the 0 after that, because remember, that's what part 2 of the fundamental theorem of calculus tells us to do. Okay, so make sure that you do that first, and we'll take it from there. Actually, I'm going to do it down here because we're going to run out of room. All right, so let's go ahead and simplify. If you want to, you can do 1 over 4 times 2 to the u all over ln of 2. If you want to simplify this, you don't have to do it this way, by the way, but you can do it as 2u or 2 to the u minus 2 if we multiply across all over ln of 2. So if you want to do it that way, that's perfectly fine. If you want to do it that way. So, and then in that case, if we had the integral of 1 over 4 times the integral from 0 to 4 for 2 to the u du, given that we simplified here a little bit, we could just write it as 2 to the u minus 2 all over ln of 2. So if you want to simplify with a constant earlier, you can. It's up to you. Or you could do it the other way and multiply the constant through at the end. Doesn't matter. So just wanted to mention that very quickly. Okay, so what do we do now? So we go ahead and substitute in our limit and see what we get. So this is 2 to the 4th minus 2 all over ln of 2. And this would be minus 2 to the 0 minus 2 all over ln of 2. And you see what you get. So it looks like we get 4 over ln of 2 minus 2 to the negative 2nd ln of 2. Okay, this also can be written as 4 over ln of 2 minus, well, we have 2 to the negative 2nd, so 1 over 4 all over ln of 2. And then we get our calculator here to get 4 minus 4, which is 15 over 4. So this becomes 15 over 4, all divided by ln of 2. Okay. And that would essentially need to be simplified. If I got another sheet here. Okay, so what we got is 15 over 4 all over ln of 2. Well, that's just 15 over 4 times ln of 2, which would be the answer. So your final answer here the integral from 0 to 1, it was 2 to the 4x dx. So the answer here would be 15 over 4 ln of 2. All right. So, yeah, I hope that makes sense. So let me circle that answer for us. And that is your answer. So let me know if you got any questions about what was done. I'll try to answer it as best I can. All right, so I'll see you guys next time.